is Aishwarya from EC department. I welcome you all for this session. So it's about Single Slope ADC. It is a topic from Unit 4 LIC subject. So in this Single Slope ADC, we consisting of ramp generator, comparator and one AND gate and the timing control unit, BCD, latch, decoder and then finally our output in the digital formation. Okay. So this is for the construction. So in the single slope ADC will generate one single ramp signal. Okay. So we will discuss how it generates. Okay. So in this condition we apply the input signal to this comparator. In the initial stage there is no signal in this ramp generator. Okay. That is the ramp generator will started here. So initial stage there is no signal in this ramp generator. So in this condition the comparator will be given that higher value to this AND gate. We already know that AND gate means whenever we getting higher input in the both input terminal, that time only it will be generating output. Okay. So the highest is given to this AND gate and the clock signal, the second input of AND gate is clock signal. We know that clock means we have to positive negative. So whenever the AND gate will get the positive signal, that time only the AND gate will produce the output. Okay. So while it will produce the output means the BCD will start at the counting process. So it counting start from 0 0 0 0 to 1 1 1. Okay. The last value is 1 1 1. The initial value is 0 0 0. So initially it start the counting process. So now we have the values 0 0 0 0. Okay. So in this condition the timing control will be turned off. So the ramp will start the process of generation. So in this condition it will start the generation like this. So in this time again the signal is given to this comparator circuit. The comparator will be compare the two signal and it will give the higher input. So in the condition clock also in the positive mode. Again the AND gate will produce the output. The second value will be counted. Same process continued until the BCD will reach this higher value. Okay. Once it reach the higher value, that signal is stored in this latch circuit. Okay. So that time, the timing of control will give the reset signal to this latch and this ramp generator. So this 1 1 condition, when the BCD reach the 1 1 condition, so that till that time the ramp generator will be generate the waveform like this. Okay. So after resetting the latch will be send the signal to the decoder, then we will get the digital output by using this circuit. Okay. So this is what single slope ADC. Okay. So next one is dual slope ADC. So dual slope ADC means the construction wise we have to additionally add one integrated circuit. Okay. So let's see. So next one is dual slope ADC. So in this dual slope I told you the difference is we additionally add one integrated circuit in the input side, right? So in this dual slope we have two inputs, one is DI and one is D reference. Okay. So next one is integrated and then our comparator and our AND gate, binary counter, latch and our digital output. Okay. So initially we have to apply the input signal, that is our analog signal, to this integrated circuit. The integrator will integrate that input value like that. Thus, the output of the integrator we have to know that what is that? Minus 1 by RC integral of V into dt, right? So in this time the integrator start the integration in the towards negative. Okay. Towards negative side. So that signal is given to this comparator. The minus signal is given to this comparator. And the next one is in the non-inverting terminal is grounded here. So this signal is 0. The comparator will start the comparison in this condition. The non-inverting terminal value is higher than inverting terminal because the minus value is lesser, right? That is 0. Comparatively 0 is higher than -1. So the output is 1. So that signal is given to this AND gate, then a clock signal also provided. So clock signal like this, positive, negative, positive, negative. Whenever we are getting this positive clock pulse, that time AND gate output also 1. So the binary counter will start the counting process, start from 0, 0, 0, 0, 0. Right. So again that same signal, again the next signal is applied to this inverting integrator. Then integrator start the integration process again towards negative. Okay, towards negative. The process will continue until the binary counter stop the counting. That is, the output is finally 1 1 1. Whenever we are receiving this 1 1 1 1 output, that time this binary counter will enable this switch is switched to B reference side. So while we switch this B reference side, the minus B reference signal is applied to this integrator. So that signal, that time the minus into minus will goes to plus. So the plus signal is given to this inverting terminal. In this condition, comparator output goes to 0. So when whatever clock pulse we apply, this AND gate output will be 0 here. Okay. So that time the integrator will reach that B reference signal, it start the integration towards positive side. Towards positive side. So this is the process of dual slope ADC. So after counting, the latch will be receiving signal and we will get the digital output here. Okay, this is the process. So why it's called single slope, dual slope means in single slope ADC, the ramp generator will generate a single ramp signal only, right? So that it is called as single slope ADC. So in this graphical method, this dual slope ADC will generate two